So, good evening, everyone. My name is Deepak Kumar. I'm currently doing undergraduate. I'm a undergraduate student at IIT Kharagpur. I'm currently doing research internship at Maritime Research Center. So, my topic is dark ship detection and classification using SAR imagery in the Indian Ocean region. So, this is the structure of my presentation. So, moving to the introduction part, basically, maritime domains covers all the different activities in the sea and ocean regions like fishing, trading, resource exploration, and national defense. So, with over like 90% of global trade are used are being uh, are being moving through ocean only. So, like uh, these are being done through the vessel. Vessel is basically a type of watercrafts. These are watercrafts. They are called vessels. So these are being done through the vessels and like transportation and operation at the sea and ocean regions. So vessels are basically uh, integrated with the AI system to get tracked. Basically, AI system is used for the identify the ships, their location, their speeds, and other informations are there as well. So the problem basically with the vessels are AI system. AI system in the vessels can be turned off, and those vessels are called dark vessels. So due to this, the tracking of those vessels is not possible when AI system is turned off. So they do this basically to bypass the laws and get into the unrestricted zones to basically do the smuggling, illegal fishing in the unauthorized zones. So this is mainly the issue in this one problem. So basically, we are looking into the Indian Ocean region. So the main issue is why this is a problem in India. Basically, India has a vast coastline, like around 7,500 kilometer, and like it demands like large scale maritime surveillance. So basically, in India, most ships are very small. They are being used for fishing purpose only, but mainly illegal fishings are done by these ships, and they doesn't have any AI system. Or even if they have AI system, they basically try to turn off them so to get illegal activities. So sorry. Uh, so maritime. So this is the problem in the when AI system is turned off. So there are existing solutions which also has some limitations. Basically, AI's tracking is done. Basically, AI is used but when they are turned off, tracking doesn't get happen. So the other system they used is coastal surveillance radar. Like it has limitations of like around they can cover around 50-kilometer range from the shore region, but they cannot go into the deep sea region. So there is one more satellite is there which can be used, which is optical satellite. Optical satellite takes high resolution images of Earth, but it is limited by like clouds, weather, and night time. Like it can be detected in this situation. So SAR images are used. SAR images are taken by Sentinel-1 satellites. So these are images which can take images even at the night situation, different weather situation, even if there are clouds are there. But they are very noisy and have flutters and so ships are those small ships are basically get hidden in the noises of the images basically. So traditional method were used for detecting these ships basically from star images, which is called CFAR. So this method is basically used to detect these ships, but small ships still can't be seen from these images. So they basically try to automate this detection part through SAR images using the models. So few of the models has been developed and which are integrated with the SAR images to get the basically get the ships. So, but still, this is the issue in this models is the detection of small ships. So, basically, small ships in the Indian region are they are being used vastly for this fishing part. So, this is the issue. So objective of this project is basically to develop a model for those ships which doesn't have any AI system, or if even if they have, they turn off their AIS. So using the SAR images. So SAR images is basically taken from this satellite Sentinel-1. So like the SAR images which will be fused with the AI's data So this helps in the getting the information, required information of the region where SAR images should be taken. So this integration should be done. So this model basically will help in near real-time maritime surveillance and like in around the Indian region. So data we will be needing here is the AIS data. AIS data has a lot of information like the identity of the ship information, the dimension basically, navigation, where they are heading, where they are located, latitude and longitudes, and the time step, basically the time where when they are situated in that position. So these are the data provided by the AIS. And the second thing is SAR images. SAR images is provided by this Sentinel-1, and the model which I'm going to use is using the C-band SAR images. So these C-band SAR images are converted into high resolution star shape detection images. So these images are specifically pre-processed from this to this to get the shapes. Basically, what you are seeing here, this highlighted brighted part is shapes. So these SAR images is basically processed to get the high resolution SAR images to get the shapes. So the architecture of model is to basically use the YOLO model. It's a type of model for the detection of those shapes, but we have base YOLO model. But for the detection part, the research paper is I'm following is using a enhanced YOLO model. So the structure is basically mentioned in the paper. So these are the structures basically. The structure formulation is like SRB log SPD module and hybrid attention mechanism. So these structures are basically used in that model to get the detection of small ships. So this basically boosts the detection of SAR ships, which are in the SAR images. So for the explanation of model architecture, so these model architecture basically each of the modules which is constructed inside the architecture of the YOLO model. So the SR module is basically helpful in the improving the feature of the uh, pixelated images. So basically the highlighted images of ships are basically used by this SR module, which improves the richness of the those pixels. So SPD module is there, which is used for the preserving the small targets basically. And HA module is helps in the boosting the signals and the clutter, reduce the clutter noise. And this is the loss function. Loss function is basically targeted to build basically reduce the losses of small boxes. So small boxes are specifically for the small ships. There are large and small ships. Both ships are there in the SAR images, but to reduce the loss function of those small ships, we have used this new loss function. So these modules are basically integrated in this architecture. So this architecture is basically layered with these modules to improve the model architecture of U-loop model. So till now, basically these things are being done. The SAR and AIS images are basically collected, and they are being SAR images are being processed. This processing part is required to get the HR SID images, which will be helpful in my model. The model will be using these HR SID images to get the detection of those small cells. So I've trained on basic YOLO model, which I have mentioned earlier, the enhanced YOLO model for the comparison with the enhanced YOLO model. So this is the basic YOLO model confidence curve. Confidence curve basically telling is how much basically around 38% of the ships are being detected with 90% confidence. So this is what F1 confidence is telling. And this precision recall is telling basically with over 50% of confidence, around 94% of ships are getting detected. So this is a very good result in basic YOLO model. So you can see the validation result. So this is the validation result. These are the annotated ships. These are already fitted in the images. These are annotated ships are basically here, present here, but model tries to detect those ships, annotated ships, with the confidence. So you can see the most of the ships are getting detected with 90%, and few are there with 30% or less percent again. So like the moving to the novelty of the approach, basically this approach is basically targeted to detect the small vessels with over like with those vessels which has size less than 20 meter. So those ships doesn't have mostly AI system. So Basically, this focused on the non-cooperative ships in Indian coastal region. Like most ships doesn't follow the rules and regulations of Indian regulations, so they are basically called as non-cooperative ships. So like we are trying to basically build a foundation between SAR and AI system. So we will be using both the informations to get the small ships in the Indian Ocean region. So for the looking forward part, like what will be going to be done, like to enhance the YOLO model, basic model on high VRAM GPU, so that the performance can happen using that enhanced YOLO model. So pre-processing part of the SR images to HRSID images, which is required for the model, and the automating these processes. Basically, these processes should be automated so that we can get the all the things in one group, and which will be integrated with the AI's data, which will help in the getting the information of ships. So concluding this presentation, like small AIs of vessels, to like these are very serious threat to the Indian, and also like for the border security purpose also, like this is a threat. So this approach is basically reliable for detecting those small ships mainly. So this model is basically optimized to get the small ships in the Indian Ocean regions. So this groundwork will be helpful in the surveillance of those ships in the Indian Ocean region. So this is the end of my presentation. Yeah, thank you. Thank you, everyone.